Hello everyone and welcome back to my YouTube channel. So this is the part number 2 of the fashion recommender system using deep learning. So in this part, we are going to test our applications and also try to build the web application using Streamlit. So without any further ado, so let's get started. So now it's time to test our fashion recommender system, right? So for that, I am going to create here new Python file here. So let's say test.py, right? Test.py. Cool. So you can see here two files appear on here. That's called featurevector.pkl, which actually store the feature extraction of the 2048 feature in one single vector, and the file names, right? This means file names are your pictures. So now we are going to test our model, and also we need to load those pkl file here. So this is the feature extraction.ipnb file that we already do in our Jupyter notebook, right? So if you missed the video part number 1, so please go and check out. Otherwise, you cannot actually understand this video because this is the testing part. So now we are going to test here using one picture. That's when we just give here one picture of our model, and our model give here the 5 images as a recommendation. So this is the picture of the show. So just we actually pass here these images, and our model actually give you the 5 images as a recommendation. So for that, we need to also process this image, right? So what I'm gonna do here, we just copy this line from here. Just copy this line and paste here the test.py file, and also import here the model files because we also need the model, right? Then what I'm gonna do here, we also need to do it. That's our model. And then we are going to take the image as the input, and we are going to actually using here the canon to actually classify the images. That's we need to give here one neighborhood of the 6 images. That's not 6, actually 5 images. So for actually this is nothing but one unsupervised algorithm. That's been unsupervised learning technique. So that's why you need to actually cluster the algorithm, because there is no label. As you can see in the folder just have images, there is no label. So this is the clustering problem, right? So for that, we actually using the canon to actually get the 5 neighbor images of the file names. So now what we're gonna do here, just we are going to actually do the same thing for the images. So now we need to actually copy this function, right? This is called the extract feature that we actually define in the part number 1. You also need this extract feature 1. So now what we're gonna do here, we need to also import here CB2, right? So let's say import CB2, and also you need to import here the norm one, right? Norm and also the numpy. So let's say import numpy as np, and also you need to actually import the norm function from the numpy len log. So let's say from numpy dot len lag and len lg, import here the norm one. That's mean these norm functions, right? So now we are going to actually load our images. That's our these images. Then we need to also load our this feature vector.pkl file and also the file name. So for that, we need to also import here the pkl. So let's say import pickle pkl. Now you're going to load the image, load the feature vector and the file name, right? So let's say this our feature list. Let's say feature list equal to we are going to actually give here the pkl.load pkl. So this should be the pkl.load, and inside that we need to give here our the readable file name. So this readable file name is nothing but called this feature vector. And also, so okay, when you actually load the file, right, you need to also open it, right? So for that, you need to use here the open function, and inside that open function, you need to give here the feature vector and the mode of the text mode. So it's our the write mode because we actually load here from our directory. So for that, just I'm going to actually copy this feature vector dot pkl file 1. So let's say copy and paste here the name and pkl, the extension, okay? And we need to do the same thing for the file name also. So just we need to change this into the file name, and also we need to actually replace it with the file names. So that should be file names.pkl, and this is also the write mode. And now we need to convert this feature vector into the numpy array, right? If you actually trying to load this, you need to actually convert this pkl file into the numpy array. So for that you can use the np.array function. So let's say np.array, and just we're going to pass here this inside these np.array functions. So our feature vector is also loaded here. So now what we're going to do here, so we have the normalize. If you actually give here one image and the models, it actually give here one normalized result, right? So cool. So now we need to actually define here one clustering algorithm so that we can actually recover the system, because we have one feature vector of the images. So now we all are done. So now let's run the code. If there is any problem in the code, it actually give here the error. If it is work fine, that means we can actually jump on the next move. So let's say test.py. So it takes few seconds to actually load all the things here, because it will load here the ResNet 50 and also the feature vector and the file length. So later on, we actually do here the clustering algorithm. That's me actually using the nearest neighbor to actually cluster all the feature vector. Okay, so we got our the ResNet 50. That's mean we have no error. We don't have any error in our code. So now what I can do, we can actually pass the images, okay, and get the normalized value, and we can actually using the cluster algorithm to actually take some recommendation. Let's actually give you the 5 images, right, as a recommendation. So to actually using this cluster algorithm, we need to also import it here. So it is available inside our scikit-learn. So let's get from sklearn dot neighbors. We are going to import here the nearest neighbor. We actually using here the nearest neighbor because based on our feature vector, we just going to calculate the Euclidean distance of each feature vector, and after that we can actually return the 5 recommendation of the images file name, right? So for that, what I need to do, we need to actually also initialize this nearest neighbors. So this initialized neighbors take some parameter as argument. First one is the number of neighbors. That's mean how many neighbors you needed, and the radius, and the algorithm, and the leaf size, and the matrix. So we need to actually initialize here a few things. First one is the number of neighbors. So not say n neighbors. We can give here 5 or 6, whatever. So let's give here 6. And the radius, you cannot, you don't need to give here the radius here. It's already set up as a default as a 1. And now the algorithm. So what kind of algorithm are you actually using here? This nearest neighbor. We actually using the brute force method to actually taking all the feature vector, to actually using the brute force algorithm to actually taking all the feature vector, and you're going to actually calculate the distance of each feature vector in a Euclidean method. So the algorithm should be the brute force algorithm, right? So let's say algorithm. So the algorithm is nothing but our brute force algorithm. So let's say BRUTE, and the matrix, that's in our metric. So which metric that you're going to use, because we are going to calculate the Euclidean distance with each feature vector. So for that, we actually using the Euclidean as a matrix. So let's say Euclidean, right? So we need to actually store it inside one variable. So let's initialize this variable 1, okay, neighbors. So now using these neighbors, we can actually fit our result, right? That's in our fit our this feature vector. That's in our feature list. So for that, we're going to use here the fit function here. So we're going to fit our feature list, okay, this feature list. And after fit with the feature list, so we can actually calculate the distance and the indices of each feature vector. So distance is actually give here our the actual distance with the feature vector with the 5 feature vector, because we recovered the 5 images. So it actually give here the 5 nearest neighbors of each feature file length, and later on we can also show it using the OpenCV, right? So for that, what I'm gonna do, we are going to actually in these neighbors, because inside these neighbors we can actually using here the canon. That's mean the can neighbors. We need the can neighbors of our images. So let's say using the can neighbors, these neighbors, and inside that we need to give here our normalized images. So this one is a function. So what I can do, I am just going to actually break this function into one single images. Just we need the normalized value, because we already train our model using this normalized value, right? And just give here this image path. So let's give here the image path. Let's say 16. That's mean these images, this show images 1636 cool. So now you're going to actually give here this normalized value, and this normalized value actually give here 2 values. One is the distance, and another one is called the indices. That's mean indices of your the feature vector. Okay, that's mean nearest feature. So it should give here the 6 nearest feature, or you can give here the 5. You can also give here the 5, so that you need to calculate it from the 0. Okay, so now what we're going to do, we're going to actually loop through this all these indices, so based on our file name. So let's say for file in indices, because this indices actually give here the file name, right, based on this feature list. Okay, so this indices, so our indices should be actually start from the 0. So we can also start from the 0 to the 5. Okay, 0 to 5, that's mean actually give here the 5 value as the indices. So if I make it 6, so we can actually start from the 1 to 6. That means it actually give here the 6th value, that is 5 value. As it is same, you can give here 5 or you can give here 6. It's up to you. So now based on the file name, we can actually read it here, because this indices give here the file name. If I am comment out this line, and if I am trying to print here these indices, let's say indices, so these indices, so let's actually save the file and go to the terminal and run here this python test.py. You can also run it here, python test.py. So it will load it, and it will also process the images. Okay, and after that you actually give here the 5 file names, okay, as the recommendations. Then you can also show it after the indices. So you can see here it will give here this file name, this name, file names, this file name, this file name, this file name, this file name. 1, 2, 3, 4, 5, 6. It will give here the 6 file names. Okay, so because we give here the number of 6, that means 6 images, so that's why I actually give here the 6th one. So now if you're actually using here the file names, okay, so we can also show it using the OpenCV. So let's try this out. So just use here for file in indices. So you're going to actually load it using the what you call cv2.imread. So let's read it based on our file name. So this file name, because we're going to use here this file. So we need to actually put this file inside our file name, because this file name have all the information of that, whose position actually stored. Because if I open the terminal, I think I close it, right? So it will give here the 6 value. So 6 value is nothing but the position of the each file. So if I actually using this inside our file name, okay, just if I can show it, just I am going to put it inside our file name. So if I'm trying to print it out, so let's say try to print inside file names to the this indices, not indices, this file. So if I run the code here again, and it will actually give here the complete file name of that. So let's say python test.py. I have to give here the 6th file name. That's mean this file name is actually containing inside our dataset folder, and it will recommend these images inside our dataset folder, right? Because the file name is actually stored all the file names one by one, so that's why. Okay, you can see here the file name. You can see a dataset 4113, 4171, and like that. And this is the image name that already stored in our dataset folder. Okay, if I'm showing it, let's say 4113, right? 4113. So it will maybe here. So maybe this one the image of the show. Yes, right. This is the image of the show. If I am see it 4117 1. So let's say this one in the 71, 41171. Right, so where is it? Yep, this one. Yep, this one also image of the show. That's been our model actually working fine here. So now we can also show it using our OpenCV functions, right? So now let's see how can we actually show it using the OpenCV functions. So we can also comment out this line. So let's say cv2.imread. First you need to read it, and later on you can also show it. Just you need to copy this file name, and let's say this should be the image img. I think, okay, I already actually initialized this image before. So let's give here image name call, and now we are going to also show it. So for that we're going to use here cv2.imshow. Okay, and inside that we need to give here the frame name. That's in our window name. Let's give here the frame, and just paste here this image name, and also need to give here one white key. So cb2.wait key. So just give it here wait key. So cache should be capital, and let's give here 0. Cool. So now if I actually save this file, and also let's close this data set, and if I go on the terminal and type here python test.py, and it will actually load the TensorFlow image system, and I will take the image as input as a 1636. It will give here the 5 recommendation of the images, and you can also show it, right? Okay, this is quite big. You can see here the image of show, right? So I think it will give you the 5 images. Okay, this one also image of the show. We can also resize it. Okay, it's better. We can also resize it. You can see this is the image of the show. So let's resize it in some format. So we can actually use here cb2.resize, and you can actually give here the image name and our, what do you call this, our the width and the height. Let's say we'll give here 640 and 480. Okay, cb2.resize, and we have another bracket. We can also run it using this run button. Okay, so it also run on this file in the Visual Studio terminal. Okay, you can also run it inside your terminal. Just go on the terminal and type the python test.py. Okay, take few seconds to load that first time. Yep, good. So first image, the second image as a recommendation, and the third, and the fourth, and the fifth. Okay, we can also get here 6. Okay, we didn't get here 6 because we gave here the indices as the 1 to 6. If I give here the 5 and give here the 0 to 5, let's say this 0 to 5, and we can get here 5 images, right? So you can also give here 1 to 5, 1, 2, 3, 4, 5. So to give you the 5 images, right? Cool. So now what I'm going to do here, we are going to actually creating one web application using the Streamlight, right? So this is almost same to actually create one application using the Streamlight. So for that, what I'm going to do here, we are going to actually create here another Python file. Let's call main.py. So now what I'm going to do here, I'm going to paste here some code. So this is the code for the web application using the Streamlight in Python. It's called Streamlight or Streamlit. Okay. So you need to also install this library on your system. So for that, you need to open your command prompt here, cmd, and type here the pip install, and the library name is called Streamlit. Okay. So I'm not going to install this library because it already installed in my system. So I'm going to click it to close that. See, this is almost same feature list and the file names and the models and also the struct feature. Just you have two function. This is new. One is the save upload file and the recommend file. This is not also new. Just we actually define it. And this is the code for actually testing our images, and until the code for the recommendation of the 5 images that it show in our web applications. So let's discuss about that. So we actually discuss about this thing here. This is easy. So import all the things here. We import pickle, TensorFlow, import NumPy, and also the global max poly in the ResNet 50, and also import here the CB2, right? So this is the function for save upload image. That's mean when you actually click the upload button of your web application, it actually select one images. So you need to also store the images inside your upload folder. Okay, so inside this upload folder, we can actually extract the images, then we actually get the images, and based on the images, we can actually give her the recommendations. Okay, so you can see here st.title. So this is nothing but the title of our web applications. So when one user actually click on the upload button of our web application, it actually select here one images and store inside the upload folder. But there is no upload folder. So you need to also create this upload folder, right? So let's say upload. So let's say uploads. So actually stored inside our upload folders, and you can see upload file dot name. Okay, based on the name of the files. If you are selecting from the D drive or the E drive, it actually stored based on this file names inside this upload folder. And till the write mode, and you need to also write it inside our folder. Okay, and if there is no error, it actually give here the 0. 1. If there is no error, that means your picture is uploaded correctly. If there is error, it should give you the return as a 0, right? Then this is a function for the extract a feature. That means 2048 feature vector, and this is a function for the recommendations. So this is almost same nearest neighbor, and to take the feature list and also indices and the feature. Okay, it should give you the indices. Based on the indices, you're actually going to recommend it. So now you're going to actually create here one file uploader. So uploaded file equal to st dot file uploader. So this st is nothing but the streamlight.st sst. So st dot file uploader. So this file uploader, you can also print the file name. So if the file upload file is not none, that's mean it have some value. Okay. So just we're going to actually save it inside our save upload folder. So if save upload folder, we're just going to pass here the save upload folder, and it will simply upload inside our these upload file folders, right? Then we can actually get these images inside our upload folder. So for that, we actually using here the pil, that's in pilo library. So from pil we input here image. So using this image, we can actually open this whole images, and we're going to resize this 20 cross 20, 200 cross 200, and we're going to show it on our st.images. That's mean when the user actually click on the chosen image button, then they'll just store inside our upload folder. They're going to take the images inside our upload folder using the image, that's in our pedo library, and we can also resize it so that it can show it clearly 200 cross 200, and we can use this st.image resize image. So now we're going to actually give here this display image, that's been our uploaded file image inside our extract feature. Okay, that means this is the feature extract part. So it will actually give here the feature extraction. Then you can give here this inside our recommend. That means this recommend function, and this recommend function actually give here our indices. That means this indices. So this indices containing the file names, right? Then we can actually give here the indices inside our file name. So now we're going to show here the 5 images, right? So for that, we actually use here the st.beta column. Then we're going to show it based on our file names, and we have our file names here, this file name. Just you're going to pass here this file name and indices and 0, 0, 0 position, 0, 1, 0, 2, 0, 3, and the 0, 4. So if I go here, this test.py, you can see here indices 0 and 1 to 5. That's been 1, 2, 3, 4, 5. Just you're going to show it based on the actions. That means 0, 1, 2, 3, 4. That means there's a 5 images. Okay, and if you see here the neighborhood is the 6th. If you actually give here the 6th, that's been column number 6, you can also show it. Okay, so if there is any error, it actually show here some error occurred in the file upload. If there any occur, is actually upload error actually occur inside your when actually upload the file. That's mean if it give you the return as 0, that's mean maybe there should be some error when actually upload the files, right? So this is the code for the web application. So don't worry on that. You can also get the code in a GitHub link. So don't worry, but there should be one password, and the password name is fashion, just fashions. Okay. So now it's time to actually run the code. So if I'm trying to run the code, just go on the terminal. You can run this file, just go click on here, because this is one Streamlight file. So not this is one Streamlight web apps. So you cannot run this file using the Python main.py. If I'm trying to run it, just type here the Python main.py. So it will give here error because you import here the Streamlight. So you need to actually run this Streamlight in the Python. So you need to give here one command that's called Streamlight run and your file name. Okay, right. So you can see here it also give here the one warning. Streamlight your main.py. If you just copy this command, and if you actually run this file here, Streamlight run main.py, so it will actually open it in your local host. That means it will open on your one web server. So let's go on the full screen mode. I think my voice is not clear. I'm so sick, that's why. So you can see here man and the woman fashion recommended system. So drag and drop file here. If I click here the browse files, So you can select one images here. So let's select these images. Just click here to open, and it will show the images of the 200 cross 200. That's been the image that you actually load here using the pillow library. And it will actually give here the 5 recommendation. Okay, you can see here, please replace st.beta column with the st.columns. You can also show it. I think it is removed on this date, so that's why you can also use the st.column. Let's go on the Visual Studio Code again. So let's close it. You can replace it with this column. You don't need to actually run it here, the st.beta column. You can also use it. So if I go on this upload folder, and you can see here the images that I actually selected. So that is actually stored inside our upload folder. So now what I'm going to do here, I'm just going to actually go on the terminal again and run the code here. Okay, so this is called the streamlit run, and your Python file name, and your Python file name is main.py. Okay, so you can see here network URL. It will open in your local host, and you can see you're running. So cool GUI, cool application using Streamlit. You don't need to use here HTML or the CSS or JavaScript to actually upload the file. Like there's so many functionalities, so I can actually use the Flux. So it's better you can actually using this Streamlit. Okay, so click here the browse file. So let's select here this show of the man. So it will take that as an image as an import. It will show it, and now it's time to recommendation. Cool. It recommend me the 5 images. Okay, maybe there should be one wrong one. So let's browse here another. Okay, so let's browse here this t-shirt. We can also test it out from the images from the internet. You can also test it out for the custom images, so that we can check this out that our model actually working here fine or not. So we just test it out for the 3,000 images, maybe 2,906 images. So if you use here more images, so your model should be more perfect. So this is all about the whole tutorial. Make sure that you subscribe to the channel and also support me, the Knowledge Doctor. So I'll be back with another tutorial. So till then, take care and bye bye.